is entitled Core Concepts, Understand the Kubernetes Cluster Architecture. So the first thing we're going to understand is what is Kubernetes. Essentially, it's an open source platform for managing containerized workloads, and sometimes referred to as a container orchestration system. At its core, Kubernetes consists of a cluster. So that's essentially what is being run, the cluster. And a cluster consists of one or more worker nodes, basically another machines that are running your container workloads. Another piece of the puzzle is something called the control plane. It's a set of services that manage the cluster, and it's running on one of the nodes. It could be running on a node that is with a worker node, or it could be running on a node that's just got the control plane on it, sometimes referred to as the control plane node. There's different topologies, which we'll talk in a minute. Another piece of this is there's a database service that hosts all the data that the Kubernetes cluster has. It's spelled ETCD, and it's pronounced etsd. And so that database essentially, there's different topologies about where that database is being stored. So I think this we'll talk about now, sort of the different configurations or cluster topologies. So first, you can have a single machine, essentially. That's a worker node, right? It's holding the etsd database, as well as it holds the control plane services. So it's just everything's in one host. Another solution is where you've got a single host that is essentially the control plane and the etsd database, right? And then you can have multiple worker nodes that are running your containerized applications. That's another configuration. There's another option, which is a more high availability option. It's referred to as the stacked etsd, basically where you have more than one control plane node with etsd database running on it, right? And then you have one or more workers or worker nodes. So you have multiple. Basically, the key here is you have multiple control plane nodes running the control plane for redundancy. And then the most fault tolerant or most highly available solution is sometimes referred to as external etsd. In this case, we have got multiple separate hosts just running the etsd database. That's all they do. We have multiple hosts that are basically control plane nodes, and then we have multiple worker nodes. So that way you have redundant database, redundant control planes, and then of course you've got multiple worker nodes. So that's the most highly available solution. Next, so before you go to install a cluster, you need to actually have some sort of network out there, right, to host all these worker nodes and the machines running the control planes. And so there's sort of two main ways of organizing your network. The more simple solution is you just have one public facing subnet, right? Public subnet, and you just dump everything in there. That would be one solution. More secure solution, and AWS's recommended solution, is you create actually a private subnet. That's where you put all your worker nodes, all your control plane, everything that's kind of Kubernetes is in there. And then you have a public subnet where you allow Kubernetes to create things like the load balancers, which are external facing. So it's a private public solution. And the good news is when we use, and we're going to do that build today, when you go to use, let's see if I can find it here. When you go to build your Kubernetes cluster using Amazon's Elastic Kubernetes Service, EKS, right? When you do that, one is you get a highly available solution, right? Where you actually have a separate control plane and separate etsd database, right? They're redundant, right? And these are spread across multiple availability zones. And then you also have the benefit, you have the option, which is the preferred option, to create a public subnet and a private subnet. So this diagram here, I'm just going to walk through this main diagram here real quick. So first of all, you will notice that the control plane and the Ec2 database are outside of your VPC. So that, Amazon manages that completely. It's on their network, right? It's redundant, and according to their documentation, both of those are spread across multiple availability zones for redundancy purposes. Okay. Now, when you do your build, you will get a new VPC, right? And you'll have multiple availability zones. And so what you're seeing here is essentially what one availability zone looks like. And in this case, we'll have two. When we do our build, we'll actually have two availability zones. So this top part's duplicated down here, right? So in there, let's start from the right here. First of all, you will get a node, a worker node, in your private subnet. And the term that Amazon uses, this is more of an Amazon term, that basically the auto-scaling group that automatically manages your number of worker nodes is called a node group. So when you create a node group, it creates an auto-scaling group to manage the number of nodes. Okay, so that goes in your private subnet. And then, of course, because you have a private subnet and a public subnet, you'll get, in part of your build, you'll get an internet gateway for the public subnet, and you'll get a NAT gateway that manages your traffic for your private subnet. One of the things that you will want to do also separately outside of the build, the tools or the documentation we're going to go through, since you want to be able to log into your node to do some troubleshooting, your worker node, you need some sort of host that lives in the public subnet that you can jump through. So you basically log into this host, and then from that host you can log into your worker node. It's often referred to a bastion host or a jump box. So that's just basically you just go ahead and set up some sort of Ec2 instance in your public subnet, and then you can then do that jump. You can use it to get to your worker node, and we'll illustrate what that looks like. That is that. Oh. Okay, so let's go ahead and I think we're done with this, and we're done with this. Okay, so I'm not going to do the instructions with you on the screen because there's quite a bit of steps, but Amazon provides excellent documentation on getting started with basically building your EKS cluster, right? There's two solutions. One is called EKS control, which is the top option, and then there's also with the console. So two things. One is using EKS control is very easy because you basically have one command line that does everything for you. The bad news, you don't see necessarily all the options. You're not exposed to a lot of the things that are under the hood. So in this case, I actually went through the exercise of using the console and just kind of went through each of the steps. It took me probably an hour to do. Making sure I didn't make any mistakes, right? Now, one thing, just as a side note, I did try to use this EKS control just a couple days ago, and it didn't work. And it looks like there's some issue created where it's not currently working. At least it doesn't. I had the same error that someone else had reported, so pretty sure it's not me. So for now, I would highly recommend just going through the console installation because it's, one, it works, and two, it is more informative. And then you'll want, once you get that up and running, following these instructions, you will definitely want to create a bastion host or just any EC2 instance running in one of the public subnets, and then you will use that to get, we'll do it later, to log into your worker node. Okay. Okay, give me a second. Oh, okay, so one side note. Let's see if I can find it here. Let me just go into the project on GitHub. So this is, of course now I can't find it. Here it is, tutorial. Now, just as a side note, I also It's not required or terribly important for you, but for my own exercise, I went through and actually created a Terraform configuration that essentially replicates what is being automatically built when you use, say, the console or EKS control, right? It builds out your various VPC elements and builds out your cluster and your nodes. This Terraform script actually does the same thing. And so if you know Terraform, you can actually use this. If you do use this, one important thing in here, there is a variable here you'll want to change. There's a key name. That's your SSH key that you're going to use, right? And another thing, if this is all configured for US East 1, so if you want to change to a different zone, you'll want to change, there's 3 lines you'll want to change. You'll want to change, there's a provider entry here, and there's 2 availability zones. You'll want to change those 3 things. It's a complete side note though, Terraform is not part of the scope of this video, right? Just in case you wanted to do it though, you're welcome to do it that way too. You're also welcome to look to see what the config looks like. Okay, so after you go through the whole exercise of following the instructions to build your cluster, you will see that you have a cluster. So let's see. In this case, mine's called K8S CKA tutorial, right? There's not a lot of information here necessarily. You can see that my nodes are running, well, anyway, we're not going to go through a lot there. You will also know that when you go through this exercise, you will get a new VPC, right? So you will see a new VPC created. So now I have more than one here, right? Normally you only have one. And I must have left one around because there's actually 3. I need to delete one actually. But that's that. Let me think for a minute. That distracted me. Oh, and you also will notice that you have Ec2 instances, which are your 2 worker nodes you'll have, and then if you created your jump box or your Bastion host, you'll have it. So 2 of these are worker nodes, and then 1 is my Bastion host. Okay, so we're going to switch gears. Actually, I'm going to pause the video for a minute and get reorganized, and we'll do some poking around. So one of the first things, I think that one of the last steps of installing, I'm going to confirm that, towards the end of this whole process, one of the things they'll have you do is you run a kube control, actually there's even a further one here. I think it's called, let's see if they have it here. Yeah. So there's a kube control get nodes. That command will basically list out the nodes in your cluster. So I'm going to kind of end with that, or start this conversation with that. So kube ctl get nodes. And you'll see, actually just ran it twice now, but you'll see I'm running 2 nodes, right? And so it looks like it's operational. Next thing we want to do, now that we know that our cluster is running, there's a couple things under the hood here that when you did this whole configuration, kube control is the command line tool that you're using to basically interact with the Kubernetes APIs, right? And there's a folder called, a lot of folders. There's a folder in your root directory called .kube, and in there there's a config file. Now there is also a command line. You can look at that config file directly, or you can run a command called kube control config view, and this will basically list out your configuration. Now I actually deliberately, yours will look a little different. You'll notice that I have pretty much of everything. I've got 2 clusters, I've got 2 contexts, and it looks like I have more than 1 user, right? And that's because I've been exploring different things, and I actually had used the same tool to interact with 2 clusters. And so one thing that's important to note here is that kube control can be used to interact with different clusters, but you actually have to switch which cluster it's pointing at. And one of the things here is called the current context. And you can see it's pointing at my K8S tutorial, which is where I want. If I wanted to switch it to another context, right, I would look at another context. For example, my old one was called just called tutorial here. If I go like this, and I use the command which is kube control switch context is config use context. Then I paste in the name of the context. And now if I do kube control config view, you'll notice that the current context now changed to the tutorial one, right? If I want to switch it back, which is really what I want to do, then I will grab the name of the context that I want, which is this one. And again, a context essentially is a combination of a user and a cluster, right? So that's what it is. So if I do kube control config use context, then I paste in back, and then I'm back to that context. And if I do kube control get nodes, I should see my two nodes again. Okay, so that's one of the things about just how kube control works, the kube config folder, and then various commands to switch contexts. Important if you're working with multiple clusters. Okay, the last thing I'm going to do, we're just going to wrap up this exercise by just going through the exercise of logging in to our worker node, and maybe just run some couple commands there to verify that things look fine there. So the first thing you need to do is, presumably when you set this all up, you have a PEM file that you used for your Bastion host, and ideally it's the same PEM file, that's what I did, for my Kubernetes cluster, right, for the worker nodes as one of the configuration steps, right? So in my case, I have a single PEM file, and I believe it's in my folder. It's in my folder called to-dos or us.aws. So I have a PEM file called ubuntu laptop.pem. So one of the tricks you can do if you're, I think this is probably good for Mac or Linux. I have no idea about Windows, to be honest. But in this case, you could actually, instead of having to do, normally when you want to connect to a host, you have to go, and then you have to give an I, and then you mention the PEM file. There is a tool called Secure Shell Agent, and you can use a command called Secure Shell Add, and then you can mention the PEM file. And what that does is it basically adds that PEM file to like a keychain that Secure Shell has access to, so you never have to keep on providing that, that PEM file. So to illustrate that, let me go to my instances, and I'm going to log into my jump host or my Bastion host. So that's this one. And I copy the IP. So if I go like this, normally I have to do -i, but now I can just do ec2 user at this, and if all's going well, I'm on my jump host or my Bastion host, right? Now the problem now is if you want to log in your worker node, you need that PEM file again on this on the Bastion host to go over there, which is not the best idea to keep your PEM file on your Bastion host. So there's a trick. Turns out that you can run that same command you did earlier with a minus, since now the your PEM file is stored in your keychain. This is like running in some sort of agent mode. So I'm going to do the same thing with the capital -a. Nothing special there. But the key here is, because I did this -a, I can actually now log into my into one of my worker nodes. So if I can find that private IP, which is here, right? I should be able to now go secure shell paste, and now I'm logged into, yes, I'm logged into it. And how this worked, just so you know, is that that PEM file actually was served off of my own machine, and it kind of was a tunnel basically through Bastion host. So I never had to store my PEM file on the Bastion host itself. So it's a little trick there. Okay, the last thing, so now I'm sitting on my worker node, and I'm going to just run a couple commands to verify. I'm going to go to sudo mode, right? And I'm going to run a couple commands to verify that I'm actually on the worker node and things look normal. So, and we'll talk about the details of this later, but I'll just do it right now. One of the things I'm going to do is I'm going to verify that there's a service called Kubelet, which is an important service for worker nodes, as we'll see later, is actually running. So system control, I ran system control status kubelet, and you can see it's running and it's active, no errors or anything. So that is a key part of Kubernetes service. And then behind the scenes, Kubernetes also uses Docker under the hood to actually run the containers. So you can actually run a Docker command like Docker container ls. And you can see that there are indeed some and these are actually, you see all these K8s and Kube. These are definitely Kubernetes services running. And so that also tells me that Docker's working fine. And we'll look back at this and we'll actually understand what these different containers actually are, and maybe in the next section. Okay, so I believe that is really, and again, most of the work you will do on your own to actually create your own cluster using the instructions that Amazon provided. And again, that's there's a link in below there's a link to this in the body of this the page that you saw the video from, but it is you can also just look for it. It's basically the Amazon EKS, the user guide, and it's basically the getting started with Amazon EKS and getting started with the console. Thank you.